In this lesson, you'll learn more about the inner joins we were discussing in the previous lesson. Let's see what the inner join is all about. Usually, data in the real world is saved in more than one table. To retrieve data from these tables, the most common type of join used is an inner join. In the previous lesson, we've learned that an inner join begins as a Cartesian product and then filters the results to remove any rows that don't match the predicate in the on clause in the SQL 92 syntax or the where clause in the SQL 82 syntax. You can use either syntax and SQL has similar performance results, but when you're using other types of joins, you will see that using the on clause gives us the logical separation between joining the tables and filtering the results in the where clause. And as discussed earlier, an inner join returns only rows where a match is found in both the input tables. And if the join predicate operator is the equal to operator, it's known as an equijoin. Now let's see the syntax of an inner join. You specify all the tables that you need in the query in the from clause separated by the join operator, and the on clause specifies the columns on which the join is being performed. It is recommended to use table aliases so that the query is more readable. And the table order doesn't really matter in the inner join, unlike the left outer and the right outer joins. In this example, the from clause defines the input tables, which are the orders and the order details tables. SQL Server then performs a logical Cartesian join on these tables and passes the results to the next phase. The on clause gets the virtual table and then filters the data, returning only those rows where an order ID table in the orders table matches the order ID in the order details table. The resulting rows in the virtual table are then passed on to the next phase, which is the select clause. The select clause sees that it only has to display the order ID, order date, product ID, unit price, and the quantity columns, and then just displays those columns in the result set. Inner joins may be performed on a single matching attribute, such as the order ID like we just saw in this example, or they may be performed on multiple matching attributes, such as the combination of order ID and product ID and such. Joins that match multiple attributes are called composite joins. When you're writing queries using the inner joins, it is preferable to use table aliases not only for the select list but also for expressing the on clause. And you need to use the join keyword once for each two tables in the from list. For example, if you have a two-table query, specify one join. And if you have a three-table query, you will use join twice, once between the first two tables and once again between the output of the first two tables and the third table. Most of the time, join logic is based on matching values between the columns specified in the on clause. But it's also possible to include the logic using the greater than, less than, not equals, and such operators. Now let's see some examples of the inner join. The query on the left results in all the products and its categories from the categories and the products table joined on the category ID column. So that join is based on a single matching attribute, which is the category ID. The query on the right displays all the cities and the countries where both the customers and the employees live. In the on clause, you can see that the join is performed on both the city and the country columns. Since this join is based on a multiple matching attributes, it's called a composite join. Now let's see how to join three tables in an inner join. Let's open a new query. Let's say we want to see all the products, their suppliers, and their category information. To do that, let's do a select product name. Let's grab the category name and then the supplier company name from products and call it P join categories as, let's say, C on P dot category ID equals C dot category ID. And then do another join to the suppliers table. Let's call it S on P dot supplier ID equal to S dot supplier ID. Let's execute this query, and as you can see, all the product names, the category names, and the company name from which it is supplied from are in the result set. Let's say you want to sort the result set by the alphabetical order of the product name. You can do that by using the order by clause, and let's say product name. Execute it, and as you can see, the whole result set is now sorted in the alphabetical order of the product name. In this lesson, you've learned about inner join. In the next lesson, you'll learn about the left outer and the right outer joins.